Okay, so let's move on to next one, which is setting up a virtual environment. Now, what is virtual environment? So it's a very integral part of Python ecosystem, and basically what it does, it isolate your working space from rest of the system. So you'd be wondering why we need that. Because when you're working on multiple projects, you need to have, or sometimes requirement that you must be using certain version of certain packages, right? And if you do not have virtual environment, then if you install it at system wide basis, that means only one copy, then there is no way you can work on multiple projects. Like for example, if you're working on some legacy project where you need a older version of package, say pandas, right? And then you started working on another project where you need a latest version of that on the same machine. It's very hard to do that, because once you install the latest version, it's going to override the other one, right? So there is no way to go around it unless you use a solution something like virtual environment. And it also helps in like I've listed that one why we need virtual environment is sandboxing, which is I just mentioned, which isolate your working space, so nothing else in your system will be affected. And if you have multiple virtual environment, then they are not going to interfere with each other, so they are totally separate sandbox. That's why it's called sandboxing. Second is package dependency isolation, which means that that also I mentioned that it's not going to overwrite your packages. So one package might depend upon another package, and that might depend upon another package, and the dependency is such that they depend upon a certain version of that package, right? So in certain project, you might be using package A, which depends upon package B, and package B's version 2, right? And in another project, you maybe this is the latest version you have installed a package A and B, and the dependency is such that package A depends upon package B's version 3. Now, if you have a virtual environment, it's possible to do this kind of segregation so that package dependency can be maintained. And third advantage of doing this is reproducible environment. So basically, it's a requirement that when you ship your product or solution in production, then it should behave exactly same as it behaved during your testing, right? So one component to alter that behavior is that the environment where the software will operate has changed, which means your underlying libraries and packages has changed compared to what you tested on. And that becomes a problem, especially if you're working on a very big project where hundreds of packages are being used and a number of people are working. Now, using virtual environment is pretty easy. To create a file which is called, which we'll see later in videos, that and we will be doing this again and again, a file called requirements.txt, which basically lists all the packages in the environment with exact version of that. And if you just give that file to someone, they can run a simple one line command and they can recreate your environment. So there is no fuss, right? There is no headache of keeping track of packages. And that's why we need virtual environment, and it's essential. So here is the pictorial representation, like just what I mentioned. So in previous videos, I said that for every project we are going to create a folder. So here there are 3 projects, 1 folder per each, and they are separate Python versions used. In our case, we have used PyEnv as a Python version manager. So using PyEnv, you assume that we have created this folder, and using PyEnv we have activated this version for this folder. So that is the local PyEnv activation. Similarly for this, okay. Then this bottom area, this is where the virtual environment comes in. So using virtual environment within this project, I can install certain versions of the packages. So if you see, here it is shown that same pandas package is used in 3 projects, but if you see the versions, they are different, right? So this is Python 2.7. I don't think is used anywhere, or maybe some legacy code is there, so Python 2 is being used. So this is a good example where you got a legacy project where Python 2.7 is being used, okay, and you were already working on project B where you're using Python 3, pandas 1.2 was installed, okay. Now this project comes to you, and it is a requirement that because pandas 1.2 is not going to work with Python 2.7 because this is the newer version built for Python 3, then what do? You cannot work on the same machine. So virtual environment comes to the rescue, where you create a virtual environment totally separate from this project, install and activate Python 2.7 and just install this these versions of software here and work separately on this, and this. They are not going to interfere with each other, okay. Okay, so how do we create these and manage these virtual environments? Like we have seen that PyEnv is required for managing Python versions. Similarly, we have virtual environment managers. So there are various options, but generally 3 are very popular. One is very popular within the community is Anaconda. From Anaconda distribution, the package manager is called Conda. So this already I have mentioned. Another one is very powerful and popular nowadays is called Poetry. So this is very similar to if you have ever worked on JavaScript based project where npm you use npm as node package manager. So Poetry works in very similar way. So if you have worked in JavaScript, then using Poetry you'll feel at home. What we are going to use is Venv and Pip. So these are the native tools that comes pre-packaged with Python installation. So we do not need to install anything for these. For these two, they are third-party tools, so you have to install them separately on your system. So I'll just show quickly. So if you search Miniconda, now previously I have shown you the site of Anaconda, which is the distribution, which is the complete thing, and that comes if you install full Anaconda distribution. I do not recommend that because it comes, I don't know, hundreds of GBs of software will come, and most of it you're not going to use it. If you do that, then the Conda package manager comes with that. But if you want to use Conda as a package manager, then I advise to use Miniconda instead, which is a cut down version or bare bone version of Anaconda. So Miniconda, if you come to this site, this is the Miniconda, and here they have installation. So if you can go, and for various operating system there is a installation for this, and then you can go through it's a different way of managing. So if you are interested, you have to go through the help and all. I'm not going to use this in this video series, but if you are interested, you can go through that. Okay, so this is Miniconda. Similarly, you have Poetry. So Poetry is another package manager, and this is very similar to npm. So, and very powerful and very capable tool. I have not used it extensively, but there is a learning curve involved here in this case. So if you want to check it out, if you want to use this one, this is also very popular. Now what we are going to do is we are going to use Venv and Pip. So this is what I'm going to demo now, how to use it. Okay, let's see how Venv and Pip they work together. So I am in my home directory. So if I do PyEnv versions, so currently my global version is set as 3.12.5, and let's go to our demo directory which I created during the Git installation. So let's treat that this is our project directory. So I'm in here, so there is one file, and if I do PyEnv versions here again, this is showing same because there is no local version set up here. So very first thing after creating the project folder is we need to choose and set the local Python version. So in using PyEnv, what we can do is local, and let's say I want to use the latest one, which is 3.13.2, right? Okay, so now you can see this is my local version, and we have seen this. If I go out of this directory, I do versions again, then you'll see global is this. But for this particular project, this is what my Python version is going to use. Okay, so this is the step number one, activating or selecting a local Python version in the folder, project folder. Second step is to create a virtual environment. So for this, we are going to use inbuilt Venv command that comes with Python. So what you want to do is Python -m Venv, and this is the command. One more thing probably I forgot to mention earlier during Python installation is if you are on Mac, then possibly you have to use Python 3. So instead of doing this, you have to do Python 3 -m Venv. This is because Mac OS ships with Python 2, some version of Python 2, because some of their housekeeping tools are written in Python. So it ships with that, and if you just type Python, you'll get to put some version of Python 2. That was true, I think, when the last time I checked. Right now, I don't know. But if you are getting Python, just check, issue the command Python. If you're getting version 2, then most likely you have to use Python 3. Okay. For Windows and Linux, you can use Python -m Venv. This is the command, and Venv. So I am this name you can choose .venv. I'm giving it .venv, and this is where all your local packages will be installed by pip, right? And this directly is up to you. You can name whatever you like. I am giving it .venv. So that's it. And remember, you should be inside your project folder, which is git demo. So let's do that. Shouldn't take long. Okay, so now if I do ls, I can't see anything. So in Unix, if you want to see anything with dot in Unix based system, it's hidden. So if I want to do I want to see, then I have to do a is the command. So I'm going to do ls -la. So in this case, you can see this is .venv, which is a directory which has been created. Now you can see a couple of more dot directories starting with dot. .git, we already discussed that it is for git to manage. We don't need to touch it. .python version is the this is how PyEnv manages your local version. So when I switched it to local, this is what the file it has created, and in this file there is nothing, just the version name. And the .ven is a directory. This also we probably never need to touch, because pip is going to install everything in here. And if you want to just remove the virtual environment, you just delete this directory. It's as simple as that. Okay. Now step number 2. So step number 1 was choosing and selecting a Python local version, which we did using PyEnv local. Second step is to create the virtual environment, which is this. And third step is, before installing any package, you need to activate it, because even though directory is created, system doesn't know that it has to use it. So we have to activate it. So how do we activate it? So command is source.venv scripts activate. Okay. So now if you see here .venv, that means this environment is activated. All right, so once the environment is activated, then we can install using pip. So if, let's say, I want to, there is a very popular library for making HTTP calls in Python. So I can do pip install requests. Okay. All right, it's asking me to if I want, because the pip that shipped with Python version is older, so it's asking me to upgrade it. If I want, I can just run this command to upgrade it. I'm not going to do that. This pip is fine. And remember, this what this guy is doing, it's installing the package, but it's installing locally in this Venv. All right, and if I wanted, I could have given a particular version number with the request to grab that particular version install in this project. Then I can go to different project, activate that project's virtual environment and install the same request package but different version, and these two will be totally separate. Okay, and that's the whole point of virtual environment. So I don't think there is anything else to it. One thing I want to mention is the installation which I did after the activation. This thing we are going to do again and again as and when we need certain library or packages. But the first steps, 3 steps which we followed: activating or selecting the Python version using PyEnv, then creating the virtual environment. These two things we have to do only once when we start the project, and after that, whenever we need to install anything, we need to activate it and then install the package. So this is going to repeat, and you'll see that we are going to do this again and again during the course of this video. Okay.